Welcome back. Today we will be continuing with our tower defense series, and we will be working on enemy AI. Before we start, make sure you definitely check out our Discord. We post almost everything there, whether it be game updates or whatever. There's also lots of polls, so make sure you check it out. So now let's get straight into the tutorial. So we left off last time with a bunch of tiles. I have the prefab we use for our enemies in our game. I just quickly imported that right over here. So our enemy model. Created a script called enemy AI and set up 2 points. As we mentioned in our lerping video, our enemy is going to move from here to that cylinder to this cylinder. They're small, so a little bit hard to click on. So let's open up our enemy AI script. So now that Visual Studio is open, we can open up our script. Remove the comments. And here we are. So what we want to do is we want the enemy to, from when it starts, to move here. And then when it gets here, rotate and move here. Now you can hard code this, but I know many of you may have a very different looking tile structure than I do. You might have a bigger one, more rows, etc. So because of this, I'm going to create a very simple lerping program that will let you move from one point to another and then to another. So first I want to create public transform. And we want several of them, so we'll put in a list. Transforms. Now we always want to move to the first transform on our list, so we don't know how many we're going to have. To check that in Unity, we'll do for each transform in transforms. This may cause a few errors, especially if you're using tab to end it, as transforms is actually a definition in Unity. So we can just change this really quickly to move points. That way it doesn't get confused. Now we want to create a vector3 lerp. Now, Unity will also give us issues, so we'll just write m before it. So my lerp is equal to vector3 dot lerp transform dot position, and we also want to do move points dot position, and then 0.1f should work. Now we want to set our transform dot position equal to mlerp. Now this will happen for each of them. However, what will end up happening if we click play in Unity is it'll move a little bit towards here. One moment. It'll move a little bit. Oh, we didn't assign our transform. Make sure we do that. So we have 2 points, cylinder and cylinder 1. We can rename these later. Now let's test. As we can see, our thing just teleports there. Now to make it in slow motion, we can add a few zeros here to make it a lot slower, so we can actually see what happened. You can see our object is moving towards the cylinder very slowly. Now if we just move it a little bit ahead, it'll start becoming slower as it gets closer. We can try speeding it up a little bit. Maybe that was too many zeros. And we can see our thing moves in a diagonal instead of moving here and then here. we want it to follow the path. We don't want it to just skip a bunch of tiles. So what we can do is we can tell it to keep on moving towards one tile and then move towards the other. So for each, we want to do this, and then we want to do something like if physics dot check sphere move points dot position 5 and then we want to create a layer mask for our enemy and put that here, enemy mask. This will check if anything is within 5 units of this cylinder, and we want to say if something is there, then we want it to go ahead and repeat this. Now this won't work in a for each, as the for each will run at once, but what we can do is we can create a integer. I'm going to make it public, but you probably should make it private. Public int pause none. Now what this is going to do is this will allow us, let's straighten out our code, to define which order in the array will be called when we reference it. So basically what that means is if we go transforms and then we do pause none. Now we always want that at the beginning to be equal to 0. As we can see, the first element is always 0. Here we want to make pause num be plus equal to 1. So it moves to the next point. Now this means this will repeat it until it reaches the point and then start the next one. So now let's create our enemy mask. So create new enemy mask and then assign this to enemy mask, yes, change children, and enemy mask. Now let's try. We can see we move to the 1 point. Now another thing we haven't noticed is that it does go there, however it does not turn. And the reason for this is that it cannot find a object without a collider. So if we put a mesh collider on this, and a mesh collider on this, you can see it moves there. Now, let's make sure that actually stays. So mesh collider, make sure they all have it. And there we go. Now we notice that when we click play, our enemy moves here and starts spamming 900 now of these error codes. And if we didn't collapse them, this gets very annoying very quickly and also can sometimes crash your game when you're testing it, which is not fun, especially when you have it saved. Now, to fix this, super simply, we want to check if transforms dot length is greater than this, which will universally check if the size as it's determined here, if this number is greater than the number we're calling, then we will keep on running. However, when that becomes 2, we don't have an element 2. Or if that becomes 1, which references here, then we will still be fine. Now this works if we were to add another one and another one, as it just scales like that. So it's super simple and works extremely well. So we can just do this, move this all into here, clear the error, and then click play. And as we can see, we move. Now that happens to look extremely choppy as we kind of like are moving sideways. So a simple way to do that is just do transform.look at, and we want to do transforms pause none, and that way our object here will always look towards that. Now we want to unrotate it so that it does it fine. It will look towards here. And then as we can see, it does that. Now that looks a bit quick to me, so I'm going to slow it down by adding digits here. We can of course also make that a float and define it in the editor. However, I do not think we need to change it much until we generate more enemies. Now as you can see, when you start getting closer, it slows down. There are ways to fix it, however, I think I actually like how it slows down towards there. It makes a lot more strategy into the game. If you were to want to fix that, very simply just add a certain portion of this. So for example, I would add 0.05, which is half of that, which will happen every tick, which means it moves a certain distance towards your object, and then you can create a steady thing. Might take some math and a little bit of calculations, but should be pretty easy to figure out. Now we know the enemy actually moves here, and then we can also now eventually, when it gets here, start subtracting lives, but we can save that for another video. Thank you for listening. Remember to leave a like and subscribe. It helps me a lot. I think a large percentage you probably aren't subscribed, but I'm not going to do the whole thing with the screenshot and all that. It's not necessary. If you're not subscribed, please subscribe, basically. Join our Discord if you would like to. Next episode, we will probably focus on adding towers, which is going to be very exciting. I've been super busy lately. That's why these videos might seem a little bit rushed. I will be live streaming sometime next week, so make sure you tune in for that. And just thank you for watching to the end, and I will see you next time I upload.